Hi guys, so there are multiple ways we can solve for different parts of right triangles that we've talked about so far. The first way is the Pythagorean theorem. So our Pythagorean theorem was a squared plus b squared equals c squared. So the one leg of the right triangle squared plus the other leg squared is going to equal the hypotenuse squared. We're going to use that when we have two sides of a right triangle and we're trying to find the third. Okay, so when you have two sides of a right triangle and you're trying to find a third, that's when you're going to use the Pythagorean theorem here. Okay, trig functions also are used to find sides. So if you are given one of the angles, right, not the 90-degree angle, but one of the other two angles of the right triangle, and one side of a right triangle, you can use one of the trig functions, sine, cosine, or tangent, to find a second side length. Okay, and then we have inverse trig functions, which you can use to find one of the two angles that aren't the 90-degree angle. So if you're given two sides of a right triangle, you can use the inverse trig functions to find the angles. Okay, so we're going to go through an example of each. Again, none of this is new. We're just showing you the three different ways we have in our toolbox here. The first way was the Pythagorean theorem, right? So we know the Pythagorean theorem was a squared plus b squared equals c squared. Okay, a and b were the legs. So we had legs on our right triangle. Those were the ones that were adjacent or next to the right angle. And then your hypotenuse was the one that was across from the right angle. Okay, so the legs here, a and b, are going to be 8 and y. So we have 8 squared plus y squared. Draw y squared equals the hypotenuse squared, which is 12 squared. So 8 squared is 64 plus y squared, and then 12 squared is 144. Okay, if we subtract 64 from both sides, we're going to have 80. Okay, then to get rid of the square, you have to do the inverse operation, so we have to take the square root. Okay, and then so y is going to be really plus or minus, and it's going to be 8.9. Right, the square root of 81 is 9, so this is just going to be just a little less than 9. We can put in the calculator just to be sure. Square root of 80, right, 8.94, so 8.9 is fine. But again, because we're dealing with distance, we don't care about the negative, right? Distance can't be negative in this situation. So we're just going to say y equals a positive 8.9. Okay. So that's the Pythagorean theorem. If you're finding the hypotenuse, you could do that as well. It doesn't matter. If you have two sides of a right triangle and you're trying to find a third side, you're using a squared plus b squared equals c squared. Okay. You could also, there's other ways to do this. You could find one of the two angles first using trig or inverse trig, and then you could use one of the trig functions to then find y if you wanted. That would work too. Okay. Trigonometry. So sine, cosine, and tangent, right? We're going to do sine, cosine, and tangent when we have one angle and one side and we're trying to find a second side. Okay, so we have one side here, and we have one angle, and then we're trying to find the second side, a second side of the triangle. Okay, so first thing we do here is label our sides. So 17 is your hypotenuse. Second step is circle the angle. The x is across, right? Across is opposite and x2 is adjacent, so the x is across, so that's opposite. Okay, so we have opposite and hypotenuse, that's O and H. So that's going to be the so. So we're going to use the sine function. So sine of the angle, so sine of 59, is going to equal the ratio of opposite over hypotenuse. So the opposite is x, the hypotenuse is 17, and there we have our equation. Okay, to solve for x, we have to get x by itself, so we're going to multiply both sides by 17. Okay, those cancel, and we get 17 times the sine of 59 equals x. So we go to our calculator and we put in 17 times the sine of 59. Make sure you're in degrees. You hit enter and you get 14.6. Okay, so we're going to end up with 14.6 equals x. Okay. And the last thing we have is inverse trig. Right, so Pythagorean theorem is used if you have two sides of a right triangle and you're trying to find the third side. Trig functions, sine, cosine, and tangent, are used if you have one angle, one of the angles that's not the right angle, so one angle and then one side, and then you're trying to find a second side. That's when you use the regular trig functions. And then if you have two sides and you're trying to find an angle, that's when you use your inverse trig function. So inverse sine, inverse cosine, or inverse tangent, right? Also known as arc sine, arc cosine, and arctan. Okay, so we're still using SOHCAHTOA. Still a useful mnemonic. Okay. Label our sides. So the 36 is the hypotenuse. Okay, circle the angle we're looking at. We're looking at this angle here. Let's just call it x. It's a question mark. You can leave it a question mark. I'm going to put an x there, though. Okay, and then is the 24 across or next to? It's next to, so that's adjacent, right? Next to is adjacent. Across is opposite. So we have adjacent and hypotenuse. That's the ka. So SOHCAHTOA. So that's our A and H, adjacent, hypotenuse. So we're going to use cosine. But since we're solving for an angle, we have to use inverse cosine. So we're going to do inverse cosine. For inverse cosine, you're inputting the ratio. So the ratio is adjacent over hypotenuse. So that's 24 over 36. You input the ratio and your output is going to be the angle. So our angle we just called x. Okay, and then you just have to go to your calculator. Make sure you're in degrees. We're going to do inverse. So we want arc cosine, right? Inverse cosine. And then it's 24 divided by 36. We hit enter, and it tells us 48.189. So that's going to go up to 2, so 48.2 degrees. So that angle is 48.2 degrees. Okay. All right, so those would be your three situations. If you have two sides of a right triangle and you're trying to find a third, that's the Pythagorean theorem. If you have one angle on one side and you're trying to find a second side, that's regular trig function, sine, cosine, tangent, where you input the angle measure and your output is a ratio. And then the third way is inverse trig functions, which is used if you are trying to find the angle. So if you have two sides and you're trying to find the angle, that's when you use the inverse. Okay. And then I have one more example on here, which kind of wants us to use multiple techniques at once. Okay. So we want to find all the sides and all the angles of this triangle. Okay. So let's start by finding the sides. All right, so let's find x first. So first, let's label our diagram. So hypotenuse is across from the right angle. Let's look at this right here. Okay. And let's find x first. So x is going to be across, so x is going to be opposite. Okay, so if we have SOHCAHTOA, okay, we can use the sine function, right? We have opposite and hypotenuse, so we're going to use the sine function. Are we solving? And the question you want to ask yourself is, are you solving for an angle or a side? If we're solving for a side, then you use the regular trig function. If you're solving for the angle, then you use inverse trig function. Okay, so we're going to use regular sine because we're solving for a side. Opposite is x, hypotenuse is 11, so the sine of 30 is going to equal x over 11. Right, then to solve for x, we can multiply both sides by 11. The 11s cancel on that side, and we're left with 11 times sine of 30 equals x. So 11 times the sine of 30, and we get 5.5. Okay, so 5.5 equals x. Okay. Sine of 30 is a half, and then half times 11 is 5.5. Right, so this is equal to 5.5. Okay. To find y, there's now two ways we can use to find y. We can use the Pythagorean theorem, right? We could say 5.5 squared plus y squared equals 11 squared, right? Leg squared plus leg squared equals um, the hypotenuse squared. So that's one way, right? The other way is we could, this is going to be your adjacent side, okay? And then you could use adjacent and hypotenuse, right? And you could use cosine. So we could also do, you could say or you could say cosine of 30 equals y over 11. Okay, let's do it both ways and see if we get the same answer. So if we do this, 5 squared, 5.5 squared, they don't have a squared, so 5.5 times 5.5, it's going to give us 30.25. We probably didn't need the calculator for that, but that's okay. 30.25, okay, plus y squared, okay, equals 121. Okay, if you subtract 30.25 from both sides, you're going to be left with y squared equals, let's see, 90.75. Right? And then to get rid of the square, you got to take the square root of both sides. Right? It's going to be a distance, so we don't care about the negative, so we'll just take the positive. Right? But 121 minus 30.25, right? And then the square root of 90.75 was 9.5. Okay. So we got equals 9.5. Let's do it the other way and make sure it's the same. Okay, in this one you want to multiply both sides by 11. Right, so you're going to get 11 times cosine of 30 equals y. And if you put that in the calculator, 11 times cosine of 30, you get 9.5, right? So either way would have been fine. Either one of those ways would have been fine. Okay, the last thing we want is this angle up here. The easiest way to do it is use the triangle sum theorem. We know the three angles of a triangle add up to 180. So we can do 180 minus 90 minus 30, which is 60. Okay. But we could have also used the inverse trig functions, right? We could have used, if we have all these other sides here, we could have actually used any of them, right? Inverse sine, we could have used inverse sine. Okay, and that would have been, so if this is the angle we're looking at, we can call it Z, maybe. Okay. Right. Well, the 5.5 would be adjacent to Z, and the 9.5 would be opposite. So inverse sine is opposite over hypotenuse. So 9.5 is opposite, divided by hypotenuse is 11. That should equal your angle, which we called Z. If you do cosine, inverse cosine, that's going to be adjacent over hypotenuse. So that's going to be 5.5 over 11. Okay. And if you do inverse tangent, that's opposite over adjacent. So that's 9.5 divided by 5.5. That would also equal z. Okay, so let's try those. Inverse sine 9.5 divided by 11. We get 60. They're a little bit of a rounding issue, but 59.7 is close enough to 60, right? It's always an issue when you round. Inverse cosine of 5.5 divided by 11, 60. Okay, inverse tangent 9.5 divided by 5.5, 60, right? So if you do it any of these three ways here, or four ways, right? You could have used the inverse trig, or you could have just done the triangle something. Okay, so the idea is you have multiple tools that you can use to solve for sides and angles in a right triangle. And that's what the whole second assignment is about. Okay, so let me know if you have any questions. Again, we'll have a walkthrough. We'll do the Big Blue Button meetings. And then you can email me or text me on Remind, and I'll try to answer any of your questions.